Yo guys, what's up? Welcome back again to School Bukol channel. Our topic in this video is all about diesel generators, exhaust gas turbocharger. Watch this video if you are aspiring to be a third engineer, or if you are already a third engineer and you did not experience yet how to carry out maintenance of diesel generators turbocharger. Subscribe to our channel if you want to learn more about marine engineering. So enjoy watching while you are learning for free. After removing the rotor, insert it through the journal bearing. Using the dial gauge, measure the clearance F between the inner surface of the journal bearing and the rotor shaft, with the upper side of the inner surface of the journal bearing put against the shaft on the sliding part of the journal bearing. The part of the rotor shaft that slides against the journal bearing is known as the journal part, and the shaft side is subject to wear. Close observation of the rotor shaft will reveal the sliding width relative to the journal bearing. Wear on the journal part on the shaft is determined by measuring the diameters of the journal bearing sliding parts and the areas outside C and T. Note that the diameter of the center part of the shaft is slightly less than the journal part at the time of manufacture. Compare the measured results with the clearance standard table. Measure the knock pin diameter. If the pin diameter has been worn by 20% or more, or if it is broken or cracked, replace the journal bearing with new ones. Inspection procedure for flat part ratio. Color the thrust collar or base plate lightly and evenly using red lead paint. Lightly place the colored side against the metal surface of the thrust bearing. Rotate the thrust collar or base plate in one direction so that the red lead paint contacts the thrust bearing. Remove the thrust collar or base plate and check the transfer of the red ink in order to determine the need for replacement. If a long, deep scratch of 20 mm in length or greater is found on the thrust bearing metal surface, or if multiple deep scratches and up to a total length of 50 mm or more, replace the thrust bearing with new ones. Any visible exfoliation or cracking of the thrust bearing metal surface also indicates the need for replacement. The impeller is made of heat-resistant aluminum alloy. Use a soft object such as sponge for washing, with surface dirt removed using kerosene or warm water. Do not use a wire brush or any similar hard object. It may damage the surface of the impeller. Check that there are no abnormalities such as dents and cracks on the boss on the backside. Perform die check on the backside of the compressor impeller as well as surfaces of the blades. If any defects are detected by the test, replace the impeller with a new one. Check that air flows through the air channel to the turbine side by supplying general service air to the airway. The compressor side thrust bearing 73 and oil throwers 37 are installed to the support 361. Remove the hexagon socket head bolts 733 and spring washer 734 with the hexagon socket screw K. Remove the compressor side thrust bearing 73. Remove the compressor side oil thrower 37. Remove the O-rings 373 and 362. Carry out cleaning and inspection of compressor side thrust bearing with the same procedure as the turbine side. The ratio between the thrust bearing's length of tapered part and flat part is 1:1. However, even if the ratio has not yet reached, replace the bearing when it is anticipated that the ratio will reach 1:1 for compressor side or 1:1 for the turbine side before the next inspection. Thrust bearing are the tapered land type, consisting of a tapered part and a flat part. Oil is pulled into the wedge-shaped opening formed between the thrust collar and the tapered part of the bearing by means of the rotating action of the thrust collar, thus creating oil pressure that supports the thrust load. When the thrust bearing becomes worn, the ratio occupied by the flat part increases. Soak the nozzle into warm water to remove fouling. Avoid striking with a chisel and hammer. It will cause deformation of the nozzle blades, which is likely to induce surging and or reduction of performance. Dry sufficiently after washing and coat with rust-preventing oil for anti-rust treatment during the recovery period. If a part of the blade is broken, replace it. If the front edge is dented or rear edge of the blade is bent due to collision with some foreign object, replace it. After washing, visually inspect the nozzle while observing the following: uniform removal of fouling from the nozzle blades, formation by the nozzle blade trailing edges of a continuous line with no bending, uniform evidence of contact between the nozzle blade edge and the gas inlet casing. Soak the radial turbine blade in warm water in an appropriate container to peel off the scale attached to the surface. Dry sufficiently after washing and coat with rust-preventing oil for anti-rust treatment during the recovery period. Stop using the radial turbine blade if excessive contact of radial turbine blade tip lines and dents due to collision of foreign substance with the radial turbine blade. Due to collision of combustion residue in the exhaust gas, the radial turbine blade might be worn. If the root of the blade at the exhaust gas inlet has been worn more than half, replace it. The entire wear from the root of the blade to the tip line will not affect the strength, and it can be continuously used unless it has problems in the performance due to inappropriate exhaust gas temperature. Install the compressor side journal bearing 70. Install the turbine side thrust bearing 71. Use the hexagon socket screw K to install the hexagon socket head bolts 713 and spring washer 714. Install the turbine side journal bearing 70. Install the packing 357. Install the labyrinth packing. Install the bolts 321 and spring washers 323. Insert the rotor shaft 60A into the bearing pedestal 30. Take extreme care so as not to damage the labyrinth packing fins. Apply lubricant to the turbine side thrust bearing 71 and to the thrust collar 63. Insert the thrust collar 63 into the rotor shaft 60A. Install the support 361. The support 361 is equipped with a compressor oil thrower 37 and compressor thrust bearing 73. Install the hexagon socket head bolts 363 and spring washers 364. Insert the sleeve 64 with the match mark aligned with the match mark of the rotor shaft A. Gas seal ring 605 has been installed. While supporting the weight by hand, install the impeller 66. Align the match mark of the impeller 66 and sleeve 64. Match marks are engraved on the rotor shaft 60A, sleeve 64, and impeller 66. Adjust the positions of the sleeve, rotor shaft 60A, and impeller 66 so that these marks are in alignment. Push the impeller 66 to the very end and install it into the rotor shaft 60A. Push the impeller 66 all the way by hand and install the washer 68 by hand. Screw the locking nut 67 into the shaft end by hand. Check that the impeller is at room temperature. Tightening at a high temperature may result in insufficient tightening during operation. Turn the spanner lightly by hand until the locking nut 67 cannot move. This position assumes that the tightening force 0 point is temporary match mark. Be sure to align match marks of the impeller 66 with the washer 68. Put a match mark A on the turning angle position. Moving distance in the circumference direction is L of the locking nut 67 based on the match marks of the impeller 66 and washer 68. After checking, tighten the locking nut 67 to the turning angle position. The moving distance in the circumference direction is L with the spanner. Measure the distance S between the edge of the locking nut 67 and the end of the shaft to compare the value with that obtained before disassembly. Apply the dial gauge A to the rotor shaft end. Push the rotor by hand and measure the moving distance in the axial direction of the rotor or thrust clearance H. Apply the dial gauge A to the rotor shaft end. Rotate the rotor counterclockwise by hand and measure the deflection of the rotor end using the dial gauge A. Install the cap 69, bolt 691 and plain washer 692 and spring washer 692-1 at the end of the impeller. Install the nozzle. Install the hexagon socket head bolt 455 and spring washer 454, then install the diffuser. Install the vacuum breaker. Install the O-ring 472 to the air inlet guide 47. Assemble the air inlet guide 47 into the scroll. Install hexagon socket head bolts 473 and spring washers 474. Measure the clearance A between the air inlet guide 47 and the impeller with a feeler gauge at 4 points, top, bottom, left, and right. I am making videos of my experience here on board, not to become famous, but to share my experiences and knowledge regarding the type of machineries and its basic operation, so that when you go on board, you already have the idea and nobody will come on board as school bukol.